Hello again. This time we're going to take a look at section 2 in chapter 11, cross product. This is a almost purely math section. If you remember before spring break, we were looking at some notes that I have online in various places, the old website and now on Google Classroom. I believe I attached it to the assignment I gave you guys. This is all still pretty new to me. So anyways, if you guys do need any extra help with this stuff, I'm thinking about doing a Google Meet tomorrow, Thursday. Let's see, that would be March 26th, to try to help you guys out if you have questions and that kind of thing. But anyways, we did cross product in lab session the week before spring break, so I don't really have much for you guys to look at and reference. In retrospect, I wish I would have taken pictures of the whiteboard, but I didn't, so here we are. Anyways, so what we're going to do is review cross product. You might want to get out your book at some point and take a look at the section 2 in chapter 11, because really my notes are kind of just condensed versions of that. So take a look at my notes, the book, and then hopefully this will help you understand cross product as well. So remember, cross product is different than dot product. And that dot product is really a scalar product. You multiply two vectors and you just get a scalar result, so just a number. Dot product is kind of traditional multiplication, to be honest. Also, remember in dot product, I dot I or J dot J or K dot K is all 1, and everything else was 0. So just to write that down. So dot product was when you had A dot B, and at the end you would just get a number. And the way you do that is AB cosine of the angle between them. Or you could do unit vectors. And so you could take A dot B and do like, I don't know, 3I plus 4J dotted with 2I plus 7J or something like that. Okay, and what you would do is you would just get the magnitudes of A and B, put them here, do the cosine of the angle between them, and you'd have the dot product. Or you would write out your unit vectors, dot them together by doing foiling. So 3I dot 2I, well, I dot I is 1, so 3 times 2 is 6. I dot j is 0, j dot I is 0, j dot j is 1, so you do 4 times 7, 28, and then combine them and so forth. Pretty easy. Cross product is very similar, but still, of course, quite a bit different. See, the big difference starts when we look at the result. The result of a cross product is another vector. So a vector times a vector could either be a scalar, just the amount, or the vector. But then if you get a vector, like vector C, you could find the magnitude of vector C. And I want to be really, really clear. You don't do dot product if you only want the scalar result. Dot product is a different way to multiply than cross product. You do some similar things, but other things are different. So please don't misread this. If you just need the magnitude of C, don't do dot product. You still got to do cross product, and then you have to find the magnitude of C. Okay? Well, with cross product, you can do A cross B, and if you just want the magnitude, you do AB sine of the angle. So the magnitude of A times the magnitude of B times the sine of the angle between A and B, and that will give you the magnitude of C, if you want to call the result of A cross B a new letter. Okay? Or what we could do, and I need a little more space for this, we could do A cross B and find it kind of like what we did with dot product. So let's say A and B, looks like A is 3I and 4J, B is 2I and 7J. So you would still do 3I plus 4J, but then cross it with, let's say, 2I plus 7J. See, either way, you're foiling. You're just going to do this term times that term, this term times that term, and then add up all those results. You do the exact same thing down here. What's different is the result of I cross I and I cross j compared to I dot I and I dot j. Once again, dot product's really easy. Anything dotted with itself, I dot I or j dot j or k dot k, are all 1. So like a dot a is just a squared, the magnitude of a squared, right? But when we get to cross product, it's a lot more complicated. See, with cross product, anything crossed with itself is 0. So I cross I, let me put the little arrows, is 0. J cross j is 0. And k cross k is 0. And if you need help for understanding why that is, please go look at my notes that I have online. It pretty clearly explains that any vectors that are parallel would have a sine of 90 degrees, sine of 0 degrees between them, and a sine of 0 is 0. So I dot I, j dot j, k dot k might be 1, but I cross I and j cross j and k cross k are all 0. That's one of the first big things. Now, if you look in the book, they recommend that you create a matrix from each of these vectors and then find the determinant from the matrix to figure out what A cross B result would end up being. But as I showed you guys in lab before break, there's a much easier trick. And what you do is, instead of doing that whole matrix thing, you still continue to multiply like you've always multiplied. You continue to use foiling just like before. But now you have a choice. You either are going to use the right-hand rule every time you need to know what is I cross j, what is negative k cross positive I. You could either just do the right-hand rule. And remember, the idea is if you had two vectors, like let's say this pen is a vector and this red pen is another vector. Okay, let's say they're 90 degrees to each other. You put your right hand on the first vector, let's say this is A, and you curl it in the direction of B. My thumb coming at you guys is vector C. And once again, check the notes. You'll see all the properties of how these things relate. Okay, so A cross B would be this way, but B cross A would be into my page or away from your view. All right. So the point I'm trying to make here is you could do like this right-hand rule. If you imagine there's a k vector coming at you right there, you could try to create this little system like I've shown you before. But there's another trick. If you remember, I call this the Johnny Yomtubium trick, where we do something very simple. And what we do is you write I cross j cross k, and then write cross I and cross j one more time. You can keep going if you want, but you'll see it repeats here pretty quickly. All right, now these are all true statements. I cross j is k, and j cross k is I. Lastly, k cross I is j. Check the right-hand rule. You'll see these are all true. And what Johnny Yomtubian came up with is he said, hey, look, I cross j is k. J cross k is I. K cross I is j. So if you just remember IJK, IJ, you can just write it on your paper and go, okay, I cross j is k. J cross k is I. K cross I is j. Okay? Now what if you have a negative? Well, what do you do with a negative in regular multiplying? If this was negative I cross positive j, well, it would be negative k, because you have one negative, so it makes the result negative. If it was negative I cross negative j, back to positive k, because two negatives make a positive. So if either one of these is negative, you just make this negative. Let's say j is positive and k is negative. Well, then j cross negative k is negative I. But if this was negative j and that was negative k, well, two negatives make a positive, so negative j cross negative k, positive I. It's pretty cool. It works really simple. I cross j is k cross k is k cross I is j. Really simple. But you can go backwards. So what if I need to do j cross I? Well, it turns out it's not k, it's negative k. So if you read this backwards, positive j cross positive I is negative k. And the idea is you're reading backwards. So you flip the result. Positive I cross positive k, negative j. Positive k cross positive j, negative I. Okay? And then if you throw a negative in there, just follow your regular negative rules that we all know. 2 negatives make a positive, 1 negative makes it negative. Just follow that, and you really just FOIL things over and over again. You don't really need a matrix. You don't need a determinant. But if you like that, you can do it. I know some students have it ready to go in their calculator where they just input the elements of their 3x3 matrix, and then it just kind of spits out what you have. Just want to clarify, I only did a 2-element thing here. If we had i's, j's, and k's, you can imagine this gets a lot bigger and you got to FOIL a lot more, but it avoids the determinant in creating a matrix. So just to kind of wrap it up, dot product, you know about dot product. So go review it maybe a little bit just to make sure you're not confusing it with cross product. Cross product's a little different. When you multiply 2 vectors, you get a vector. We can still get a magnitude, but you have to do A, B, sine of the angle between them. If you have vectors given as magnitudes and an angle, well, then you're probably finding the magnitude of C. Okay? But if they give you the vectors A and B in terms of unit vectors, well, then there's no reason to find the magnitude of A, the magnitude of B, and somehow figure out the angle between them. Do this method. Do the regular multiplication FOILing method. You just got to learn how I, J's, and K's interact with each other. All right? So that's it for this time. A little bit of cross-product review. Go try some of those problems out there. And once again, don't forget to take a look at the notes. It gives you some hints on different properties. Like you can use the normal rules of distribution, but not the commutative property, because A cross B is a little different than B cross A. All right. Well, until next time.